I'm recording this video as a part 4 for solving a quadratic equation, and this is really cool video because this will use a formula, already defined formula that is able to solve any quadratic equation without doing any splitting of the middle terms. As we did in like past 3 videos, we splitted the midterms into two components and they multiply together to give the third component's number. So that was how we were doing before in the past 3 videos, but in this video we'll be focusing more in a equation. So let's give let's try to resolve this equation that we did in the part 3. Same equation we will be using to solve using the formula that has been defined by a mathematician, not mathematician, but the wide accepted formula, I like to say. So this is equation here, and we are going to take the components out. Let's compare this equation into this form: ax squared plus bx plus c is equals to 0. So if we translate this equation here to this equation, what we will obtain is a is equals to 1, b is equals to minus 5, c is equals to minus 36. Is this right? So how we do it? So we have x squared, so we have 1 in front of x squared, right? If there is no number, then we put 1. So 1 times x squared is still a x squared. So a is referring to 1 here, and we have b as minus 5. So we will take the notation along with the number. So we won't leave like this notation isolated. We keep together. So minus 5 resembles b, and similarly minus 36 resembles c, right? And the famous equation for resolving the quadratic equation is, let me write in a red color. Okay, so roots, let's define them as x is equals to plus minus b, sorry I forgot it. This should be just minus b here, minus b plus minus root b square minus 4a times c by twice a. So this is a famous equation for solving any kind of quadratic equations. And you see this guy plus minus, why? Because we always have 2 roots for a quadratic equation. So if like the roots are identical, then this entire component will give out 0. But the roots are 2 unique, like 2 separate, then there should be something resulting from this part. So let's try to resolve the equation here. So we have a is equals to 1, b is equals to -5, and c is equals to -36. Let's plug in these values into this equation, right? So x is equals to minus, this is -5, -5 plus minus root -5 squared minus 4 times 1 times -36, right, divided by 2 times 1. Let's see, x is equals to minus times minus is positive. So let's imagine here is -1, -1 times -5 is 5, plus minus root under 25, because -5 squared is 25. 4 times 36 is how? First of all, let's multiply the sign. Minus times minus is plus. So 4 times 36 is how much? Okay, let me get that number real quick. You can use your calculator and try to get that number correctly. 36 times 4 is 144. So times 2, sorry, divide by 2. 5 plus minus, so what would be this number here? So let's say this is 5 goes if you 150 plus 20 170, this should be -1 169 by 2. So what would be the root of 169? This should be 13 squared. So 5 plus minus root 13 square by 2. So we will cancel out the root and this 2. So 5 plus minus 13 divided by 2 is our answer. So if we try to solve this, what will be the two roots? If we, let's say, if we consider the positive sign, then x1 would be plus 5 plus 13 by 2 is equals to 18 by 2 is equals to 9, right? Excuse me. And the second root, so I'm reusing x1 and x2, like x suffix, and let's say like write in this notation 1, x suffix 1, x suffix 2 as the second root, x suffix 1 as the first, and this one as second root. So second root is 5 minus 13 divided by 2 is equals to, how much is it? Minus 8 by 2 is equals to minus 4. So these two are the roots of the quadratic equation using the formula mentioned above, the red box formula. So you can verify these results, but we already did in part 3, so we should be good. That's all for the day. Maybe I'll make another video in the quadratic equation, but for now I'll say goodbye to you and have a great day.